So welcome back to the channel. Now, I did a previous video on testing this DCM305E out using the UTG962 there. A comment from one of the viewers on that video is about the setting of this output limit here, the 50 ohms, to match the load that I was placing on the function generator there. And they did comment that there is a high impedance output that changes the output capability of the amplitude function. If I try and zoom in, hopefully you can see. Not sure how well that shows up. Hopefully you can see on here the amplitude is set to 10 volts peak to peak. We are on 50 ohms limit, and if I zoom around there, we are on 50 ohms on the box there, and my current clamp is reading 72 milliamps, which is the max I can get out of this. And I'll do some screenshots of this anyway, but there's my waveform actually coming out. That's just picked up off the 50 ohm load. It's 10 volts peak to peak. RMS is 3.46 volts on there, and that matches the output on the UTG962. So we'll save him, put him back there. So I'll move around and look at this UTG again. What I'm going to do is go to the utility function, go to the settings, and you can see there's a load button there. I can change that, and I've got the option of putting in a value, 50 ohms, 75 ohms, or high Z. I'll put high Z up in there. We'll go back to utility, and go back to wave, and you can see now hopefully that I've now got 20 volts peak to peak apparently coming out of the generator, or so it's telling me. If I go back to my current clamp, I'm still only putting in 71.9 milliamps. And just slide him out of the way. And if we look at our oscilloscope, you can see that our peak to peak is on 10 volts still. So the peak to peak hasn't changed, it's still 10 volts, and it's 3.47 volts RMS. Now, so if I now change the load that I'm putting in to simulate a high impedance, we'll put it up to 150 ohms, and you can see I've actually jumped up for 15 volts peak to peak there. Let's go to 250 ohms, and we got up to 16.5. But unfortunately, you see that my current is dropping. It's now dropped to 24 milliamps. Let's go up to 17. That's 18 milliamps, and that's 450. Let's go 500. But it's going down all the time. So 750. So let's go. So that's 19 volts now, peak to peak, and we're on 950 ohms, but we've now dropped to 7.2 milliamps on the current clamp there. So I'm not 100% sure exactly what happens with these units. I do know that the units have their own internal impedance of 50 ohms, and you can't change that. So what you end up with is the current going through the 50 ohm output of this function generator, and then through the 50 ohm load that I've placed on it. So you get like a potential divider here, and that's the voltage that the unit is supposed to be putting out to meet the voltage on this bottom half of the potential divider. Now it looks like when I'm doing this there is actually also some sort of a current limit at play here. The most I can get is 71 milliamps out on this. The only way I can get a higher current out is to actually decrease this load. I'll do it briefly. I don't like to do it because this is it's just an air-cooled unit. There's no forced cooling on this, and I don't really understand dropping this below 50 ohms exactly what kind of load that the unit can put out. I can't find it in the specs, but if we drop it down to 40, you can see I've now got up to 79.8 milliamps. Hopefully on there, if we zoom in a little bit, and I'm now to 8.96 volts. I'll take it back again. What I'll do is I'll just change this unit back to 50 ohms limit. To wave. So back to 71 milliamps again, 10 volts peak to peak. I can do the same again if you just zoom across down to 40 ohms. Again, 79.8 milliamps, it's consistent. Drop to 8.96 volts on the scope there. So yeah, not 100% sure exactly what is happening. It could be a combination of a current limit on the output of this, but it's also to do with the fact you can never really fully trust what the output voltage is of these on your actual load that you've got connected to it. It can change depending on how you set the loading of the unit to make sure that it does match the load that you're applying, and that's the important thing that you need to do. If you don't do that, then the output voltage that you put on there may not match what is actually coming out across your load. As I say, I believe there's also some form of a current limit acting on this. That's the most that I can seem to get out, irrespective of whatever configuration I have of the load limit on this, unless I take this below 50 ohms. So, okay, that's it for this video. I just wanted to try and provide some clarity to that, or I've probably made it even more confusing. I will leave a link to a video down below from another YouTuber who does a very good explanation of the loading of these and the effect that you have, and he explains it much better than me. I think it's W2AEW, the channel name, but I will link to that video down below and you can go and watch that one, and that'll give you a better idea of exactly what's happening here. He doesn't do current checks on it, which is primarily what I'm using mine for, but he shows you the effect of the voltage as well and explains it much better than I have. So that's it for this video. Thanks very much to Justin T, the viewer who posed the question regarding the loading. Thanks for watching, and I'll see you again in the next video.